on to lesson 15. What's that? Since the first quiz. Second quiz. It should start at 45. So it's from the 21st. What I have. After Martin Luther King Day, we had that 4-day week, that was homecoming week. So the homecoming is starting. I've got one record going, starting on the 21st. 1, 2, 3, 4. There's only been 5 homeworks. Plus the review. No. It's just been since a while ago. Alright, so we're going to start, we'll ignore my triangle for a second. Lesson 15. The geometric mean. We're going to start with reading a theorem. And then we'll talk about what a geometric mean actually is. Okay? So theorem 50-1. Theorem 50-1. Can somebody read it for me? Go ahead, Anthony.
The altitude is drawn to the hypotenuse of the rectangle, and the two triangles in the corner are similar to each other.
Okay. What was that second word? If the what is drawn? The altitude. It seems like that word has come up recently. What in the world is an altitude of a triangle? We've written this one before. It's always helpful to write it again. What in the world is an altitude? Because if you don't know what that means, you really are kind of stuck knowing what this postulate means, or this theorem means. Is it the what? Is it the height of a triangle? Altitude is the height. Planes fly at a certain altitude. But in a triangle, it's the height. Okay? More specifically, when we did this, how many altitudes could we draw? I see fingers. You can actually draw three altitudes in a triangle. Okay? How in the world are we going to do that? We did one. I don't know if we did it in this class. Each vertex. We can draw an altitude from each vertex to the opposite side. So that's what I'm going to write. The altitude is the segment from a vertex to the opposite side at a right angle. So we have to know what that is in order to know what theorem 50 is talking about. Okay? Theorem 50 also is talking about a right triangle. So I went ahead and drew a right triangle up here. The angle is drawn right there. So let's start by drawing, actually let's name it, well it doesn't matter right now. We'll name the next one. If I wanted to draw the altitudes, all three of them, if I started up here at the top, from the vertex to the opposite side at a right angle, where would that altitude be? Straight down the side at a right angle. Okay? What if I drew it from this vertex? It's going to be straight horizontally at a right angle. But this theorem specifically said from the right angle, so they want to know specifically about this vertex at the right angle, to the opposite side, which they call the hypotenuse, at a right angle. Okay, so that's the line that they're specifically talking about. Okay? And then they say something else. If we draw this altitude from the right angle to the hypotenuse, it will do something to that big triangle. two similar triangles that will also be similar with your original triangle. Okay, so if I draw purple right here, how could you classify this purple triangle? It's a right triangle. Okay, if we're just talking about angles. And then we have, we'll do a red looking triangle. What's this red triangle? Is it also a right triangle? Okay. And then I think we started with a blue triangle. Is it also a right triangle? It says all three of these triangles, the purple one, the smallest probably. Then we have a pink triangle or red, and then the blue. They are all similar to each other. What do you know about similar triangles? What's something that you know? The angles have to be congruent. The sides have to be proportional. Okay, those are the two biggest things that we know. Okay, the angles have to be the same. Well, I can see the right angle in all three of them. Okay, so, and we're not going to go crazy about angles. We're going to really talk about their side lengths. Okay, so the side lengths are going to be proportional. Maybe let's go ahead and write a definition before we move on. I'm just going to write it right here. Go ahead and write the definition of a geometric mean, because it will help. It'll help the next looking at triangles be a little bit nicer. And their definition is awful. Really, it is. I won't even sugarcoat it. It's not nice. So we'll read the paragraph around it. Sometimes the means of a proportion are equal to one another. This is a special kind of proportion that can be used to find the geometric mean of two numbers. The geometric mean for positive numbers a and b is the positive number x such that a divided by x is equal to x divided by b. So they set up a proportion. Now I'm going to go back and do a little thought bubble from about a week ago, 2 weeks ago, maybe 2 weeks ago, that we talked about cross, I think they said cross products, we call it cross multiplication. We're going to cross multiply. And we said A over B equals C over D. Okay? And their definition of cross multiplication or cross products was the product of the extremes is equal to the product of the means. And I said it, and you don't remember it, it's okay. They rewrote it like A to B, they just rewrote the proportion with colons, equals C to D. A and D were the extremes. The product of the extremes, A and D, is equal to the product of the means. So in this paragraph, when it says sometimes the means of a proportion, what are they talking about? B and C. Okay, the means of a proportion are equal to one another. Okay, so that's going to be my definition for a geometric mean. When the means of a proportion are equal. Okay, and then I'm going to use their A over X equals X over B, which means X is the geometric mean. Okay? So if you were to see a problem that said, what is the geometric mean between? Okay? And then they give you two numbers. Let's scroll up just a little bit. I'll give you an example. what is the geometric mean between 2 and 18? Now, a geometric mean is very different than the mean, median, and mode stuff. Not the same type of mean. A geometric mean, we're going to set up a proportion where the means, those x's, are the same. Okay? So we're going to set this up as, what's the geometric mean between 2 and 18? So A and B are going to be my 2 and 18. Sevens. What if I put the 18 above the x? What if I put the 18 here where the 2 is and the 2 is there where the 18 is? Is that going to change anything? It's not. So how do we solve any ratios that are equal, any proportions? We're going to cross multiply. So when we cross multiply, what do you get? 2 times 18? 36 equals, what's x times x? X squared. So 36 equals x squared. What in the world is x? 6. Now, geometric mean will be positive, so we don't need to think about the negatives. Okay, because it will be a length of something. Okay? So what's the geometric mean between 2 and 18? Your answer is 6. Because 6 times 6 is the same thing as 2 times 18. Say that again. Reduce what? Well, if we reduced it, would they reduce to the same thing? One-third equals one-third. Would it have to? That they're not asking you. 2 over 6 is 1/3. 6 goes into 18, 1/3. Do they still have to be equal? Yes, it has to work. Okay? But when they ask what is the geometric mean, we're stopping at x equals 6. Okay? So that's the definition of a geometric mean. Now, when in the world am I going to use it? Why do I need to know this? Okay? Well, you're going to have a triangle somewhere, right? So I drew a really big triangle because I'm going to label a lot of stuff. So if you're drawing a triangle, don't draw it small. I'm going to write a lot of stuff inside this triangle. First, we're going to name it. The last class made me name it Joey or Joe. And then we added the letter. So J-O-E. We're going to name this triangle Joe. And then we're going to do exactly what Theorem 50-1 said. We're going to draw the altitude from the right angle to the hypotenuse. Is that kind of close to a right angle? Not bad. And we're going to name that point Y. Okay. Actually, I could have done something first, but it's okay. So we're going to say the original triangle, being the big triangle, the blue triangle. What's the name of the blue triangle? Joe. Triangle Joe. And I'm going to start labeling stuff on the side. The first thing I see is, what is the hypotenuse of Joe? J to E. What is the short leg? If the legs aren't the same length, it has a short leg and it has a long leg. So I'm going to start talking about what is the short leg and then what's the long leg. So short leg for Joe would be O to E. I probably should have lines above them, but what is the long leg? J to O. Okay, so I'm even going to write, this is the long leg, this is the short leg, and this total thing is the hypotenuse. Didn't need the whole thing, but somebody got confused. Maybe I'll just put out the parentheses. All right, let's see about, my smaller triangle? Does everybody see my smaller triangle? So the smaller triangle, what's its name? Y. Triangle, you can name it YOE. Okay. What is the hypotenuse of triangle YOE? O to E. So that's going to be my hypotenuse. What would be the short leg? Y to E will be my short leg. Then what is my long leg? O to Y. Okay? No, we don't see exactly. Oh, that should have popped. All right, let's do a purple. Does everybody see this last triangle? It's the bigger, or the medium size, we could even say. The medium sized triangle. What is its name? Let's name it Joy. Triangle Joy. And then we have Joe and Joy, and then Yo. Sure. What is the hypotenuse of the medium triangle? J to O, right here. What is the short leg? L. It's O to Y is the short. See, that's an O. And then what is the long leg? J to Y. Okay. So are there some things up here on this list of each triangle that are the same sides? I mean, I think it should be pretty obvious. We have a short and we have a hypotenuse that are the same sides, the same lengths, but of different triangles. Okay? We have a short and a long. Okay? That are the same side lengths. They're labeled different in different triangles. And then we have a long and a hypotenuse. Okay? That they're the same side lengths. Now, what is not part of it? The hypotenuse of that big triangle. We have a short side, we have a long side, and they add together to be the hypotenuse. Little hint, if you want to go ahead and put it out there. Sometimes I call that hypotenuse a total, because it's the total of this long leg and that short leg together. Okay? That could help at some point in time. So let's pretend. See, I've tried this lesson a lot of different ways. Taking the triangles and cutting them never worked. Actually, you got a lot very confused. So I don't do that anymore. But see, I took a triangle that was a right triangle, and I cut the altitude into two different pieces. Okay, so then I could see it. But if my right angle's here, then how did I have to lay it out so they were all similar? That, if you want to see that, we can. But sometimes that's hard to see. And after I did it 2 years in a row and it kind of bombed on me 2 years in a row, I'm like, maybe I won't do that anymore. But I still left the paper in my book and it distracted me. So I'm sorry. All right, so if I have some information about this triangle, okay, what if I have J to Y and Y to E? What if I have, do I want to make it easy or do I want to make it hard? Let's don't start making it hard. Let's start with a 2 and an 8. So if, what colors have I not used? If this short side is 2 units long, okay, And this long side is 8 units long. Do we know the whole hypotenuse? Yes. Now I'm going to see if we can find all the other missing pieces. Okay? Can we do that? Wait, let's go back. Let's go back for just a second to what that theorem said. It said they were all similar. If we draw the altitude, then they are similar. What does it mean again to be similar about the side lengths? They have to be proportional. So if I want to look at this pink triangle, and I want to say the short is to the long, okay? And I want to compare the pink triangle to the purple triangle. The short is to the long. Can I say the same thing about the purple triangle? Would it also equal the short to the long? Short, pink. That's weird to write pink in the color blue. The pink short to long and the purple short to long. Well, what if I went up here and actually wrote the letters Y to E? Could I do that? Could I say Y to E is to O to Y, as this short, O to Y, is to J to Y. Okay. What pieces do I have? Do I have Y to E? I just gave you it was 2. Do I know O to Y? No, we don't. Do we know O to Y, the short side, in the purple triangle? But is it the same length? O to Y and O to Y, they're the exact same length. Do we see something there? That's geometric mean. Do we know the long of the purple triangle? 8. Can we find X? Can we find the length of O to Y? What are we going to do? Are we going to cross multiply? If we cross multiply, we get X squared equals what? 16. So X equals 4. So what does that mean, X equals 4? O to Y is 4. So now I can put a 4. I've just solved for that. Does that mean I can solve for O to E? How? The Pythagorean theorem, we're dealing with right triangles. So 2 squared plus 4 squared equals O to E squared. We can solve for that. 16, the square root of 20. Did that really quick in my head. I don't think it was quick in my head. Okay, so could we solve? I wouldn't leave it like that. Could we solve for J to O? Yes, we have a 4 and we have an 8. 4 squared plus 8 squared. That's a bigger number. 64 plus 16, that's 80. I don't add numbers in my head very quickly. It is 80. The square root of 80. I know, I would break those down. Okay? But being able to find one piece is a big deal. Okay? There are 2 other, they're corollaries that go back to theorem 50-1. Okay? We're going to read them really quick. Who wants to read 50-1-1? Go ahead, Victoria.
If the altitude is drawn to the hypotenuse of a right triangle, then the length of the altitude is the geometric mean between the segments of the hypotenuse.
So the altitude that we drew is the geometric mean, is OY, between the segments of the hypotenuse. What we just did. Can you read the next one? Go ahead, Grant.
If the altitude is drawn to the hypotenuse of a right triangle, then the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is closer to that leg.
Oh, we didn't really talk about that one, but it's going to be these other 2. And we'll finish those tomorrow. I need you tonight to write these 3 theorems. The theorem and the corollaries, okay? I'm not having any more homework. No. I did record. I need to stop, though. Thank you.
Like,
Just write the theorem.